Hi everyone, here's another video. This one's going to cover chapter 7.2 on compound interest from our textbook. Now to begin, I want to define what compound interest is and how that is going to be different than simple interest. Compound interest is where interest is calculated on the amount at the time of calculation. You'll have an exact idea of what I mean by that once I do my demonstration. So before you ask a question for clarification, please view on. Compound interest is basically the concept where the age-old phrase, let your money make money for you, comes from. Okay, if I could type it down, let your money make money for you. Let your money make money for you. Okay, it's investing 101. It's why we invest, and it makes no sense up until now if you have been thinking that, oh yeah, I'm going to study hard, get a good job, and I'm going to make a lot of money, and I'm going to retire. Then you are not letting your money make money for you. You don't need to have the best paying job. You don't need to have the greatest of education if money is your final goal. Okay? And so this is where a teacher like me would say something like, pursue your passions, do something that you are able to do for hours on end without realizing the time has gone. And the next day you sleep, wake up the next day, you can do the same stuff again because you enjoy it so much. And make sure that's not, a bad habit, like, playing video games all day, and then you wake up and you're able to play video games all day again. Okay? Anyways, I digress. To have a better explanation of what compound interest is, I am going to make a parallel with simple interest. Okay, so let's pretend your principal is going to be $1,000. I'm going to invest at an interest rate of, let's keep it simple, 5%. Okay, simple interest, what would the interest be if I keep it for 1 year? Well, PRT, P, R, and T is 1 year, which is $50. Okay, so what is my final amount? Well, it would be 1,050, right? What if I held that investment for 2 years? Well, it would be $100. So my final amount would be 1,100. And if I were to do it for 3 years, well, 1,000, 0.05, 3 years, that would be 150. So my final amount is going to be 1150. Do you see how basically every year I'm just adding 50 bucks? That is simple interest. Okay, so again, I'm going to do it one more time. If I were to hold this for 4 years, what would it be? Well, it would be 200. And so my final amount would be 1,200. So this is simple. The amount of interest is based on the principal, the starting amount. So no matter how much you gain or how much you lose, you're always calculating interest based on the $1,000 because that was a starting value. So how does that differ to compound? I am going to create a chart very similar to, in fact, pretty much the same as the thing you'll see in your textbook. Okay, year. So the 0, this is the first year, second year, third year, fourth year, and you can go on forever. The balance, how much I start with. Okay, so let's pretend on year 0, I put in $1,000. Okay, and then I wait 1 year. After waiting 1 year, I should have calculated to myself interest based on the time of based on the amount at the time of calculation. So compound interest. Pay special attention to this. How much is my interest? Well, it's 1,000 multiplied by 0.05, and that's 50. So at the beginning of the next year, how much would I gain? Or how much would I have? 1,050. This is where compound interest takes a slightly different turn. We calculate interest based on the amount at the time of calculation. How much do I have at the time of calculation? 1,050. And what is 5% of 1,050? Busting out my calculator. $52.50. You see that? Where did the extra $2.50 come from compared to simple interest where it was $50 every time? That $2.50 came from 5% of the $50 I already gained. So you earned $2.50 from the interest that you didn't work a single minute for. So add 5250 onto 1,050. My balance the next year would be $1,102.50. Compare that to simple interest. I have a $2.50 more. Let's continue. Let's calculate interest using the amount at the time of calculation. What is 5% of that? It is $55.13. Right? And if I were to copy from above, I should have earned another $2.50. So the amount should be 55. Where did the extra 13 come from? Well, after earning $2.50 from the extra $50 right here, extra $50 right here, I earned another 13 cents by applying 5% to the extra $2.50 that I earned on the previous $50. Is that sinking in? This is the power of letting money make money for you. So what is $1,102.50 plus 55.13? By next year, your balance would be $1,157.63. Compare that to before. You have $7.63 that you made doing nothing. Let your money make money for you. I'm going to do it one more time. This is multiplied, 1157.63 times 0.05. All right. I'm going to start losing track of the amount of money we have. So let's brace ourselves. $50. Again, $57.88. $50 is from the 5% of the initial. Okay. $250. The $250 here is from the $50 here. Another $250 is from the $50 here. Okay. And then another $250 comes from the $50 here. So that would be $250, $250, $250. It should be $750, right? So I have an extra 38 cents. Out of that 38 cents, 13 cents is from the previous $250. That's 25 extra cents. That extra 25 cents comes from the extra $250 plus the extra 13. I'm a broken record, but you can see how every time I make interest, it made interest on the interest. And the previous interest that you made money on made interest on the interest before. So it's basically a cascading down like a waterfall. Let your money make money for you. Where does this take us? What formula does this bring us to? The reason why your previous chapter was all about exponential functions. Do you see how your money is sort of growing, not in a straight line, but faster and faster and faster? Compound interest is the beginning of your exponential financial growth. y equals ab squared, that's going to be changed to your final amount is equal to your starting value multiplied by some kind of rate to the power of how many years you keep it there. But the rate, I'm going to give it to you as 1 plus r. Going back to our previous, the 1 is the 100%, whatever you have before, and the r is the growth rate, whatever that might be, per annum. Doesn't have to be per annum, but it's going to be per annum for now. Okay, we will do an example where it's not compounded per annum, and then you'll see how to adjust this formula. But for the moment, this is going to be our staple, and harder questions, we will take this formula and sort of adjust it. Let's take a look at some examples. I'm going to clear the screen in 3, 2, 1. Example 1 from the textbook, page 428. It says, to buy a new guitar, Gaston borrows $650, which he plans to repay in 5 years. The bank charges, oh my goodness, 12% per annum, compounded annually. Let's write down what we know. The amount that I am going to start with as debt is $650. The amount of time that I'm going to wait before I pass it off, I pay for it, is 5 years. The rate is going to be 12%, so 0.12, and it's compounded annually. Determine the amount that Gaston has to pay. That would be 6. Let's write down the formula because the first time we're doing it. P 1 plus R T. $650, 1 plus 0.12 to the power of 5. Brace yourself. What do you know about exponential functions? It might start slow, but once it picks up, what happens to the value? It grows pretty big. Oh goodness, did I do this right? Is it actually this big? Wow, even I was underestimating it. If he lets this sit for 5 years, that $650 guitar is actually going to cost him $1,145.52. $650, he waited 5 years, it's getting really high. 1, 2, 3, 4, 5 years. Okay, we don't want that. How much interest will Gaston have to pay? Well, the interest would be the total amount subtracted by principal, because if you think about it, in simple interest, you already learned that principal plus interest is total amount. So interest is equal to the total amount subtracted by how much I initially have to pay. So I paid an extra $495.52 just because I waited. Talk about inflation. Compare this to the amount of interest you would have paid if the bank charged simple interest. Well then, if the interest was simple, that is $650, 12, 5 years, he'd have only had to pay $390. But the amount of debt that he had in the first year gained interest. And the amount of interest that he gained from the first year gained interest again in the second year, while the original $650 gained interest again. You get the point. You might be, you're letting your money work against you in this case, right? The guitar store is letting their money make money for them. Let's try example 2. This one's interesting, so pay attention, please. Financial institutions often use other compounding periods rather than annual. For example, semi-annual means every 6 months, while quarterly means every 3 months. Let me try to rephrase example 2 to help you out. If you were an investor, would you want to wait a full year before you see any money pop into your bank account? Probably not. And you're not alone. So a lot of banks, instead of paying annually, they will pay every month, okay? But is it fair to pay the same amount every month? No, that's like you're making a lot of money. So again, let's get an example. Let's say your principal investment was $1,000, but the rate that you are gaining from the bank is 5%. Okay? You are supposed to gain $50 that year. But sometimes people are impatient, sometimes even banks are impatient. So they will actually divvy this up and turn that into monthly payments of $4.17. But there's a catch. If you gained if you gained $4.14, the next time you calculate your interest, are you calculating based on 1,000 times 0.05? No. You should say, no. If we're doing compound interest, you should calculate 5% on that, right? That's when the bank will say, whoa, wait a minute. Since when are we calculating 5% every month? If you are doing, so this is January and this is December. If you are getting 5% for the entire year, then doesn't it make sense that you get 0.417% 12 times? Yeah, because that equals 5 for the entire year. So this is what happens. The rate gets divided, and then the number of calculations increase. Think about it, okay? The rate of 5% got divided by 12, whereas, let's pretend we're still doing example 1. The number of years is 5, but I am calculating my interest 12 times a year. So although the interest becomes really small, the amount of times I'm calculating become really big. Although the interest rate is R divided by 12, the amount of time becomes multiplied by 12. Keep your eyes on here, okay? Keep your eyes on these two factors. So P1 plus R over T, now to the power of T. If I divide the rate by a certain number, I am going to multiply the time by a certain number. In compounding interest, our basic formula can be modified to reflect how many times I am compounding per year. So what is the N? N is the number of compounding a year. If the question says, I'm going to type this up. It's better that I type it up, so I'm going to make some space for myself. If the question says it's annually, and it's just one, it's once a year. If it's semi-annually, that's sort of like semicircle. It's going to be half of a year. So N is going to equal 2. A rate of 5% will turn into 2.5. Okay. If I say quarterly, that means I'm literally cutting a year into 4 pieces. So N is going to equal 4. I divide R by 4. If I say bi-monthly, that means every 2 months. So how many times am I calculating if I'm counting every 2 months, n would be 6. If I say monthly, n would be 12, because there's 12. I'm dividing the entire year into 12 pieces. If I say semi-monthly, in other words, every half month. Well, how many months are there? 12. I'm doing it twice a month, so the number I'm dividing is 24. If I say if I say weekly, how many weeks are there in a year? Approximately 52. Good. And if I say daily, and yes, there are situations where you calculate interest daily. Ask your parents. It's called line of credit. Okay? Ask them. Daily, n is equal to 365. There is one thing between semi-monthly and weekly, and that is bi-weekly. Every 2 weeks, I calculate. How many weeks are there in a year? 52. So if I'm counting every 2 weeks, n would be 26. The difference between 24 and 26, it might seem like nothing, but when we're talking about mortgages and stuff, it's actually very significant. So example 2, let's get back to it. What will the impact on the interest Gaston pays if the interest is compounded semi-annually? All right, let's do this. Gaston's final amount was $650. 1 plus, the rate is 5%, but semi-annually means 2. And instead of 5 years, I'm doing it twice a year, so it becomes 10. This is 650. 1 plus 0.025 to the power of 10. Watch carefully. I am comparing my value with this, after all. Okay, let's see. 650 times 1.025 to the power of 10. Oh, I made a mistake. It's not 5%, it's 12%. I was looking at my answer and thought something is really wrong. Okay, I'm going to redo this. A is equal to 650, 1 plus 12% a year divided by 2 to the power of 10. So that is 650 times 1.06 power of 10. That comes to 1164.05. If I'm going to calculate interest, that is 1164.05 minus 650. That comes to $514.05. Compare it with our previous value. Because our debt added more debt to it, instead of $495 I have to pay, or Gaston has to pay $514. Okay, it's pretty significant. Let us take a look at what that would be like if it was monthly. Let's do it. A is equal to 650. 1 plus, it's 12% a year, but I'm going to cut that into 12 years. I am calculating 5 years, but 12 times a year. So this is going to be 650 times 1.01 to the power of 60. That comes to 118085. The amount of interest, if I subtract 650 from it, is 530.85. So what do you notice about the value as I compound more often? Just as how I would want my interest to be compounded more often so that my money can make money for me more often, if you let your debt make money on the money that you're already borrowed, you're going to fall into this incredibly quickly growing spiral. Don't quote my grammar. But anyways, the questions begin like this. All right. It is very important that you know the formula. It is very important that you know the terminology to use and to adjust your formula. And it is also important to know the difference between simple and compound interest. This is why I say pay special attention to compound interest. Super important. And you will see how much more this applies to your financial future, as well as things like business school. Please take a look at page 433, numbers 1, 3, 5, 10, and 11. I encourage you to do more if you'd like. From there, please make this formula your own, because the examples that I present and the different applications of compound interest only gets more complex, as you might imagine banks to do. Best of luck, study hard, and hope to see you soon. Bye.